solve some problem on Gauss's law, which states that the net flux in a closed surface for a closed surface is equal to Q enclosed over epsilon. Q enclosed or Q inside the surface over epsilon. So here we have got 4 surfaces which is labeled S1, S2 and S3 and S4 arranged as shown. Each charge in the figure has the same magnitude. So there are positive and negative charges, but they all have the same number, same value. Which sphere has the same magnitude of flux as S1? So this is our S1, and inside S1 we can see that there is one single charge. So the flux for the S1, I will write phi1 is equal to Q over epsilon. We are just going to imagine that each charge is having a magnitude of Q. So you have plus Q, so this will be one single charge. So here we can see there is one single charge inside S1, so we can write that as plus Q over epsilon. Now if we check S2, so I'm going to now write phi 2. We want to find which of them will give the same answer as phi 1. So when you look at phi 2, which is S2, this surface S2, we need to look at all the charges inside S2. So I'm going to highlight it so that we can be clear about what we are seeing. Everything inside S2, everything. That means the charge which was in S1 will also be counted. So you have got 2 positive charges and 1 negative charge. So the total plus 2, the total charge, if I want to find Q enclosed or Q in, that will be plus 2 minus 1, that will be equal to Q. So Q in or Q enclosed, you can write Q in or you can write Q enclosed in the surface is the same thing. So for the second surface we got again Q over epsilon. So we can see that phi 2 is equal to phi 1. So the flux for the second surface is exactly equal to the flux of the first surface. And that's the answer for this question. Let's say we want to find what's the flux for S3. It's not asked here, but let's say we want to find it. Then how will we solve it? So I'm going to just remove a few stuff from here. So when they say S3, again, when they say S3, we want to find all the charges which are enclosed in S3. So let's just highlight it. This is your S3, and if we check the charges inside S3, let's just shade it. So how many charges are there inside S3? We can see there is 1, 2, 3, 4 positive and 2 negative. So if I want to find what is Q in, that will be plus 4 minus 2, that will give me plus 2Q. So phi 3 will be 2Q over epsilon, which is not equal to phi 1. Okay, so that's how we can find the flux. A common mistake which students usually do is when they look for a surface, they look at the rings only. Like for example, if I look at S3, they might look only at these 3 charges. They forget that it's all the charges which are enclosed in S3, everything which is inside S3. That's what you have to do. Take all the charges inside the given surface. Okay. Let's look at the next problem. The figure below shows 4 Gaussian surfaces S1, S2, S3 and S4 surrounding a distribution of charges. Which of the following correctly ranks the surfaces according to the magnitude of electric flux through them? So as we did before, we will find what is phi 1. So for phi 1, let's look at, this is your S1. So phi 1, what's the charge enclosed in it? It's plus 4 microcoulomb. So that's plus 4 times 10 to the power negative 6 over epsilon. So just to recall, net flux is given by Q in over epsilon. Then if we look at phi 2, let's look at phi 2. Where is 2? This is the surface 2. Look at surface 2. There are 2 charges in it, plus 4 and minus 2. Plus 4 minus 2 gives you again plus 2. So that is plus 2 times 10 to the power negative 6 over epsilon. Then phi 3, let's look at phi 3. This is, just follow the surface, phi 3 plus 4 and minus 2. Again, we get it as plus 2. So that's plus 2 times 10 to the power 6 over epsilon. Then 4, the fourth surface, there is only one charge, which is negative 1. So let's write that. Phi 4 is equal to negative 1 times 10 to the power 6 over epsilon. Now, because the question is asking for magnitude, we can just look at the numbers. So we have got 4, 2, 2 and 1. We know that 2 and 3 are equal to each other. There is only one option where 2 and 3 are equal to each other, and that should be our answer. Let's check. S1 is the highest and S4 is the least, and 2 and 3 are equal to each other. So that's how we can solve this problem. Let's look at one more problem in this. Figure a point charge of plus q is located on the x-axis. So let's draw the axis. That's our x-axis. At x equal to a, so this is our origin. At x equal to a, we have got a charge plus q, and a second point charge minus q, which is located at x equal to minus a. So somewhere here you have got minus a, and there is another charge located which is negative q. A cubic Gaussian surface with side L equal to 3a. So you are going to have a cube whose side is L equal to 3a, and it is centered at the origin. So and it's asking you what's the flux through this surface. So if I want to center the cube at the origin and its length is 3a, that means from here I should be having 1.5a to this side and 1.5a to this side, so that the side of the cube will be 3a. So if I want to let's just try to draw it. This is how the cube would be. Okay, let me try to make it proper. Okay, that's how the cube would look like. Okay, so what is the idea is, when you center the cube at the origin, so the cube is centered at the origin, half of the cube is on one side, half of the cube is on the other side. The total length of one side of the cube is 3a. That means both the charges are going to be inside the cube, and one charge is positive, one charge is negative. So q in will be equal to plus q minus q, that will give you 0. That means the flux will also be equal to 0. So the net flux through the surface will be equal to 0.